If we are given lemon juice and soap water in two different beakers, will we be able to list the difference between the two? Perhaps the list will begin with the different colors, appearance, and so on. But these are just properties that we can see. Are these the only differences? There are more. Lemon juice tastes very sour. Soap water tastes slightly bitter. Please don't try to taste it. Just trust me, it tastes slightly bitter. Is this a major difference between the two? Yes, taste is an important parameter as it takes us to the chemical properties. Why does lemon juice taste sour? And why does soap water taste bitter? Any idea? The answer lies in their nature. Lemon juice is an acid while soap is a base. Do you know what an acid is and what a base is? Let's get to know these terms first and later get into their details. To begin with, we have acids. The moment we hear the term acid, something scary or something that would burn the surfaces is what pops up in our mind. Well, that's kind of true, because acids are known to create a burning effect of whatever comes in contact with them. They can erode the surfaces or burn the skin when they come in contact with it. That's how acids are. The term acid comes from the Latin word acidus, which means sour. Yes, so are all acids sour to taste? Yes, they are. The intensity of sourness may vary in different acids, but the overall taste of acids is always sour. The best examples of substances that contain acids include
Acid is found in natural substances like fruits and vegetables. Have you heard that sting of an ant or a bee contains acid and causes the burning sensation? Different food items contain different acids. Citrus fruits like orange, grapes, mandarin, lemon, etc. contain citric acid. Vinegar found in our kitchen is dilute acetic acid. Ascorbic acid is found in guava, orange, raspberries, etc. Malic acid is found in many fruits. Apple has quite rich in absorbic acid. Most of the children love more cheese in pizza. Cheese and curd contain. We wash our clothes every day with soap. Do you know which kind of solution it is? Soap solution tastes bitter, and on rubbing on the palm, it gives a slippery feeling because it contains base. Thus, those substances whose aqueous solutions have a bitter taste and a slippery feel are called bases. Water-soluble bases are known as alkali. Students, the chemical name of lime is calcium hydroxide. Lime water is prepared by dissolving lime in water. Milk of magnesia is a medicine which helps us in digesting our food. It contains magnesium hydroxide, which is a base. The baking soda used in making cake, breads, and in other bakery items contains sodium hydrogen carbonate. When your mother cleans the window, put a drop of solution she is using on your palm and feel it. You will feel slippery on your palm. This is because cleaners are made of ammonium hydroxide, which is a base. We use chalk in schools for writing on the blackboard. Is it a base or an acid? Chalk gives a basic solution when dissolved in water. It is called.
What nature does it have? It is basic in nature, which means soap is a base, or in other words, an alkali. What do we mean by this? For now, all we need to know is that the mild bitter tasting compound is called a base. Bases, when added to water, give foam and feel soapy when touched. Bases are exactly opposite to acids. Zara and Zen were all excited to perform a series of tests on a few solutions to find out whether they're acidic or basic. Their teacher handed a few yellow-colored paper strips, and before she could return to guide them, Zen had already dropped a few drops of some solution on it. And to his surprise, the paper turned bright red. Both Zara and Zen were confused with this magic. How did the paper turn red? The teacher returned and explained that the two had performed one of the detector tests. They were supposed to detect whether the solutions given are acidic or basic. And since the yellow paper changed color and turned red, it indicated that one solution was tested. But how does this paper tell us the nature of this solution? Do you remember understanding the concept of indicators in the previous video? These are nothing but substances that help us detect whether the given solution is acidic or basic without having to taste it. So is this yellow paper an indicator? Yes, it is. And what is this made up of? It's simply a blotting paper with turmeric applied to it. Turmeric? Yes, it is. The same turmeric that's used in the kitchen. Turmeric is an excellent indicator to detect the acidic or basic nature of the solutions. In this case, the paper turned red when the solution was poured onto it. So, what did the indicator tell us? It clearly indicated that the solution was basic. Yes, alkaline substances or solutions turn turmeric into a red color. More the basic nature, brighter the red color will be. And what about acids? Acids have no color change when tested with turmeric. The color of turmeric, which is yellow, remains unchanged. The solution remains unaffected. That is how turmeric helps differentiate between acids and bases. Acids remain unaffected while basic solutions turn red. And there are more indicators are the substances that are used to detect the acidic or basic nature of solutions. We have seen how turmeric acts efficiently as a natural indicator. Now let's talk about another natural indicator, and that is China rose. China rose is a plant. So how can that be used as an indicator? The fact is, the flowers of China rose possess a good ability of detecting acids and bases. So how do we use China rose flower as an indicator? It's very simple. All we have to do is add hot water to the petals of China rose in a beaker and let it rest for some time. This solution can be used as an indicator. When drops of this are added to an acidic solution, then the color of the solution changes to magenta red or a slightly different shade of red for that matter. However, when added to an alkaline solution, the color of the alkali changes to green or yellowish green to be precise. The solutions change color in very less time. And that is how we use China rose as an indicator. However, sometimes it's not very convenient to add the indicator to the solution. In such cases, some different type of system is required, something more efficient. So in such cases, litmus paper comes to our rescue. Two colors of litmus papers are usually available: red litmus paper and blue litmus paper. The red litmus paper, when comes in contact with an acid, displays no color change but turns blue in presence of a base. In contrast to this, the blue litmus paper turns red on contacting an acid while it remains unchanged in a basic solution. This is how several compounds are used as indicators that help us in detecting the acidic and alkaline nature of solutions.